going to be graphing log functions. They're related to exponential, so refer to my previous video if you would like to see those. The first thing we're going to do is we're going to graph y equals 2 to the x power. So when we do that, that gives us y to the, 2 to the negative 2, which would be 1 over 4, and then 1 over half, or 1 over 2, then 1, then we got 2 to the first, which is 2, to the second is 4, and to the third is 8. So for logs, we're going to be graphing y equals log base 2 of x. We're just going to flip them. So this is 1/4, this is 1/2, this is 1, 2, 4, and 8, and then my x's are now my y's. Okay, so on our graphs here, and you can use the calculator if you want, when we graph this, we graph our one from yesterday, looks something like this. And then when we graph our new one, it's going to look like that. And so as you can see, they are reflected across the line y equals x, which is indicative of something being inverse. And that's our first blank, that they are inverses. So the inverse of an exponential function is a log function or logarithmic function. So the inverse of y equals 2 to the x will be y equals log base 2 of x. Y equals 3x would have an inverse of y equals log base 3 of x. And the last thing here on the front is that if we have b greater than 1, and we have b to the x to the equals n, then we have log base b of n equals x, and that's what that is, base b there. Okay, the parent function for a logarithmic function, there's that word logarithmic I used earlier, would be y equals log and then base 10 of x. And sometimes we'll see that, and sometimes we'll just see log of x like that. That means the same thing. We'll get more into that here in a little bit. So our first one, we're going to go ahead and graph y equals log 3 of x. Well, we can't do that in the calculator, so what we're going to do is graph y equals 3 to the x, and we'll come back and do this guy. Okay, so I'm putting this in the calculator. 3 to the negative 2 is 1/9. We get 1/3, 1, 3, and 9. So once again, that's an exponential. Looks something like that. So then my other one, I just switch all my values. So 1/9, 1/3, excuse me, nope, there's negative 2. 1/3 here, 1, 3, and 9. So it'll be negative 1, 0, 1, and 2. So once again, you can see that they are symmetrical. My domain is everything bigger than 0, and my range is negative infinity to positive infinity. Our domain for our exponential, if we think back to, is all real numbers, and my range is everything bigger than 0. So they flip-flopped. And that's no coincidence, because remember, x is our domain, ranges are y. So same thing, when we switch x and y's, it makes sense, the domain and range would change. All right, our next one we're going to graph is going to be y equals 1/3 of the x, and then we'll come back and we'll graph this guy. So 1/3 of the x is actually going to be positive 9, 3, 1. Then we get the 1/3 and the 1/9. So this one's going to be a little different than what we are used to seeing. So negative 2, 9 is there, negative 1, 3 is there, 0, 1. So it's kind of backwards, it looks like that. And that's that decay that we did yesterday. So when I flip all these, when I do that, I get that picture. So they're still reflected. Wait, do I get that picture? No, I don't. I'm dumb. Sorry. 9, negative 2 is down here. My bad. There we go. Sorry. There we go. So it's still reflected across the line, y equals x, just it looks a little more awkward. Our domain is still 0 to infinity, and our range is all real numbers, negative infinity to positive infinity. So for all these that we're doing, you can't put them in the calculator because the calculator does not use a base of 1/3 or a base of 4. The calculator uses base 10. So what we're going to have to do if we ever get anything other than base 10 is we're going to have to change it, or we can do it as the exponential. So same thing here, we're going to do the log base 4 of x for this one, We'll do 4 to the x over here. So same idea. We're going to use -2, 1, 0, 1, and 2 for all those numbers. So exponential, -2, 1/16 is there. So we get this picture for 4 to the x, and then my logarithmic is that one. Once again, same thing, 0 to infinity, and all real numbers for my range. Okay, and we're talking about the logs there, by the way. Last thing is all the different transformations. It's everything the same as yesterday for exponential. H, if it's negative, it moves to the right. If it's a minus sign, it moves to the right. If it's a positive sign, it moves to the left. It's opposite of what we think would happen. If it's positive on the outside, it goes up. Negative goes down. And then lastly, if it's negative on the outside, it flips. And if A is a fraction, it stretches. So that's opposite of what we're used to seeing. Okay? Good luck, guys. See you later. Bye.